Okay, this is going to be the second day we spent on 2.2, and today we're going to look at our essential question, which is how would changing the form of a quadratic equation to vertex form help you graph the function? So if you remember on the first section, what we did was we took things that were in standard form and we found the vertex by doing negative b over 2a and then taking that value and plugging it in to find the y value of the vertex, and then we can make a chart and graph it. So today we're going to look at vertex form. And if you look at vertex form, remember, is a times x minus h squared plus k. Now everything we're going to do today, we're going to make a equal to 1 to make it a little bit easier to complete the square to get it in this format. Now, completing the square, the reason we're doing that is if we can write anything in the form of a squared plus 2ab plus b squared, then that factors into a plus b squared. So these two are equal and they're the same thing. Because if I multiply this out, remember a plus b squared is a plus b times a plus b. And if I multiply that and FOIL it, I get a squared, and then I get a times b is ab, and then I get b times a is ab, and I get b times b is b squared. And so that gives me a squared, and then ab plus ab is 2ab plus b squared. So you can see that these are the same. So if I can write it so this middle term is twice what the square root of a squared is and the square root of b squared is, that gives me a middle term. If I can write it in that form, then I can complete the square. And so our steps to completing the square are simply this. To complete the square, you write it in the form of x squared plus bx equals c. Then you take half of b. You square the number you get from step 2. So we take this half of b and we square it, and then we add that number to both sides. So let me show you with this one. So if this is in this form, then this middle term has to be 2ab. Well, we already know that a, the square root of this, would be x, so that would be 2xb. And so this 2b has to equal 8, and so b would have to be 4, and then 4 squared would be 16. So if you follow the steps here, you can see that this term now, if I factor this now into a plus b squared, that would be x plus 4 squared. And if I multiply that out, x plus 4 times x plus 4, I get x squared. Then we get 4x, and 4x gives us that 8x, and 4 plus 4 gives us 16. So if I have this part, I just have to take half of this. Half of 8 is 4. 4 squared is 16. And we just add that out there. And so you can see, when we go to this, we just have to write it in this form. Then take half of b, square that number you get from this step, and add that number to both sides. So let's look at some examples. So, on this first part, they just want us to fill in the blank. So we just have to take half of b. Half of b would be 3. 3 squared would be 9. And so this would factor into x plus 3 squared, which gives us that start of the vertex form. Completing the square here, again, this, half of 14 is 7. 7 squared is 49. And so that would be x plus 7 squared. Half of 10 is 5. 5 squared is 25. So hopefully you're getting the idea of this. So this is pretty easy when they're in this form. Half of 18 is 9. 9 squared is 81. So x plus 9 squared. Half of 1 is 1/2. 1/2 squared would be 1/4. And so that would be x minus 1/2 squared. When you do these, is a plus b squared. If it's a minus as the middle term, it's just a minus b squared. So that's what happened in this case because it was minus. So same thing here, you do the same thing. Half of 4 is 2, 2 squared is 4, and so if I write that as a perfect square, it would be x minus 2 squared. So it's pretty easy when you just have to fill in the blank. But we're going to go ahead and put these in vertex form. So we just need to understand completing the square so we can transfer it to this form and then put it in vertex form from there. So remember, vertex form is this, a times x minus h squared plus k, and standard form is this. And so what we're going to do today is work on going from standard form and write it in vertex form. So, changing from vertex form to standard form, let's go the other way first. So if I'm going to change this to standard form, we just take this 3 and we change that to x minus 5 times x minus 5. So I'm going to multiply these two together first. Now it's nice if we can understand the shortcut. That a plus b squared is a squared plus 2ab plus b squared. That this middle term is double the square root of the first term and the last term multiplied together. Or if it's a minus b squared, then that is a squared minus 2ab plus b squared. So going from this, since it's minus, and you can FOIL this out, but the shortcut would be x squared, multiply these two together, x minus 5 is 5x, doubled would be 10x. And then, but it's minus 10x because that middle term's minus. And then square the last term, plus 25. And then multiply by 3, 3x squared minus 30x plus 75 plus 2. And so standard form would be that. Okay? But most of what we're going to be doing today is going from this form to this form, just so you can see how you get from vertex form to standard form. Now we're going to do it in reverse. So, you can complete the square to rewrite any quadratic function in vertex form. So here's what you're going to do on this. If you remember back to the steps, the first thing we're going to do is write it in the form of ax squared plus bx equals c. So that means we're going to move this 10 to the other side by subtracting 10. So we get f of x minus 10 equals x squared minus 8x. Now we're going to complete the square, so we're going to fill in this blank here with the number to complete the square. So now you take half of b. So this was step 1. Now we're going to take half of b. So half of 8 is 4. Then we square that. 4 squared is 16. And then we're going to add that to both sides of the equation. So I'm going to take here, and I'm going to add 16 to here, and I'm going to add 16 to here. So on this side, I get f of x plus 6 equals, now I got a perfect square here, so I'm just going to write it that way. The first term, you take the square root of this, which is x, the sign of your middle, and the square root of 16 is 4. Now I always have people ask, well, what happened to the 8? Well, remember that 8 is in this x minus 4. If I write x minus 4 squared as this and I FOIL it, I get the x squared. Then I get a minus 4x and another minus 4x, which gives me that minus 8x. And then I get the plus 16. So you can see we've just gone from here to a perfect square. Now all you do is you move this 6 back. So I'm going to subtract 6 and subtract 6. And we get x minus 4 squared minus 6. Now, it's in vertex form, so remember our vertex is hk, opposite this, so 4, negative 6. And they're going to ask you to graph some of these, so if I was to graph this, So remember, 4, -6 is my vertex. So 4, -6. My A is positive, so it opens up. Now here's the thing, all of your A's are going to be 1 on this assignment. So we can just go to the parent function. And remember, we always go over 1 up 1 and over 2 up 4 if A is 1. If A was something else, we can multiply that by 1 and 4. And again, you can always make a chart if you wanted to. But we're just going to go over 1 up 1 and over 1 up 1. And then over 2 up 4, and over 2 up 4. And so we get a graph that looks something like that. All right? Now, I'm going to show you another way you can do this, and it's totally up to you whether you do it this way or not, but some people like it, some people don't. Instead of moving this -10 to this side, you can just work on this side. So you can go x squared minus x, and then just group that together and keep that plus 10 on the outside. Now we complete the square just like we would. X squared minus 8x, half of 8 is 4, 4 squared is 16. So we added 16 inside. So remember, an equation is like a balancing scale. Whatever you do to one side, you have to do the other side. So before we subtracted, we added that 16 over to this side. But if we're just going to work on this side, what we could do, since we added 16 inside to keep this balanced, we can subtract 16 on the outside. And 10 minus 16 would be minus 6. And then we've got a perfect square, so x minus 4 squared minus 6. And again, our vertex is 4, -6. So that's 2 ways to do that. I don't care which way you do it. So let's try a couple others and see how we do. And I'll show you both ways on this, and you can decide which way you would rather do. So, first way, move the 25 over to the other side. That's step 1. Step 2, I'm going to take half of b. Half of 12 is 6. And then I'm going to square that. So this is going to be step 2 and 3. I take half of b, which is 6, and 6 squared is 36. And then I'm going to add that to both sides. So now if I write this in vertex form, or as a perfect square, that would be the square root of x squared is x, the middle sign is positive, and the square root of 36 is 6. So that's x plus 6 squared, and this -25 plus 36 is a plus 11. So now I subtract 11. So my vertex is at -6 and -11. And again, if I was to graph that, it'd be over here at -6, down at -11, then I go over 1 up 1, and then over 2 up 4, and that would give me a graph approximately there. Again, I'm just giving a rough graph on these. Okay? So, to do it the other way, just so you can decide which way you like best, we group the x's, we put the 25 on the outside. We take half of b, same steps. Half of 12 is 6, 6 squared is 36. Since I added 36, I subtract 36. And now I write it as a perfect square. Remember, we're taking the square root of this to put here, and the square root of this to put here, and that sign goes in the middle. That squared equals, not equals, 25 minus 36 is a minus 11. So, again, whichever way you would prefer to do is up to you. You can keep it on the same side. You just have to remember, if you put it in this form, you do the same thing to both sides. And if you're just working on one side, whatever you do inside, you do the opposite on the outside. So let's take a look at one more. So again, I'll do it both ways. Move the 16 to the left. Take half of 9. Now, again, you can do this as a decimal or as a fraction. I'm just going to do it as a fraction. So half of 9 would be 9 halves. And then I square 9 halves, and so that would be 81 fourths. And so I have to add 81 fourths to both sides. I'm going to change. So on this side, I'm going to put plus 81 fourths. And so I'm going to go ahead and change this 16 into fourths. And so that would be 64 fourths. And so now I'm going to get x squared minus 9x plus 81 fourths. And on this side I'm going to get 81 plus 64 is 145 fourths. And then I'm going to move it back to that side. So now I take the square root of x squared is x. The middle sign's minus. The square root of 81 fourths is 9 halves. And then minus 145 fourths. So don't let the fractions confuse you. It's the same process. Again, you can use decimals if you want. If we would have done it the other way, remember we group the x's. We move the 16 outside. X squared minus 9x. Again, we take half of 9, which is 9 halves. We square that, which is our 81 fourths. So since we added 81 fourths, we subtract 81 fourths. X, the square root of x squared is x. The middle sign is negative. The square root of 81 fourths is 9 halves. And then again, this is negative 64 fourths. And that gives us a negative 145 fourths. So, again, whichever way seems to make sense to you, I would do it that way. It's kind of nice to keep it on one side, but it doesn't make any difference. This assignment is going to be a worksheet, so it's going to be like we've just been going over. You're just going to go through it on a worksheet. So, in class, so hopefully this makes sense. Good luck.